So here I'm working on completing the square when my a value, or my coefficient of the x squared, is not equal to 1. So what I need to do is take a look at these first couple terms right here, the 2x squared minus 4x. I'm going to take this a value and divide it out of both of those. I'm going to factor it out. So what I'm going to get then is going to be 2, and then in parentheses, if I factor it out, I'm going to get an x squared minus 2x. So now I've divided it out of both of those. If I wanted to go through and redistribute, it would be the same as what I started with. Now, the 5 is still going to stay out over here. I do not do anything with the 5, so I still have a plus 5 on the outside. Now with my set of parentheses, I'm going to complete the square with that. So if I take a look at a quick sketch, I would have an x squared, which has a side length of x. I have negative 2 x's, so I'd have a negative x here and a negative x here, being a minus 1 and a minus 1. That leaves a box down in the corner. That box is going to be a negative 1 times a negative 1, which means it's going to equal a positive 1. So when I make that set of parentheses into a square, I have 2 on the outside. I have an x squared minus 2x plus 1. My plus 5 is still on the outside. The problem now is that this 1, that box right there, this 1 that I just added to the problem, which is right here, I've just added that to the problem. It was not part of the original problem. It was not at all in this step here. So what I need to do is subtract that away. However, it's inside the parentheses, and the 2 is being multiplied to it. So I did not actually add 1. I actually added 1 times 2. So I need to subtract away 2 times that 1. So my next step is going to be 2 times, my square is now, has side lengths of x minus 1. So it's an x minus 1 square plus 5 minus 2. I can go through and instead of writing that, I can now write it as 2x minus 1 squared plus 3, and is now in graphing form. My vertex is going to be a positive 1, positive 3. It has an a value of 2, so that's being vertically stretched by 2. We'll look at another example here. I'm going to start off with the exact same process where I'm going to take this 2 and I'm going to take that out. I'm going to factor that out, so this is going to equal 2 times x squared minus 3x. And the 2 on the outside, that constant term there, is just going to be on the outside over there. The problem now, when I make my diagram of this, I have my x squared, but now I have negative 3x's to divide up. So that means I'm going to have 1.5 of them on each side. So I would have 1 and then a half of 1. So I would have a side of a square being x minus 3 over 2. Same thing for the other side. But this box then down here, the ones that I'm going to be adding, is going to be a negative 3 over 2 squared, because I'm taking the 1 from here and multiplying it to the 1 over here. So negative 3 over 2 times negative 3 over 2 is going to be a positive 9 over 4. So my next step now is 2 times x squared minus 3x plus 9 over 4, that completes my square, plus 2, and now I need to figure out what I am going to be subtracting away. Well, the amount I'm subtracting away now is going to be the 2 times that 9 over 4. So I'm subtracting away 2 times 9 over 4. And now I can simplify this. 2 times, in parentheses, x minus 3 over 2, which again is the side length of my square, x minus 3 over 2. I get that 3 over 2 by taking this b value right here and dividing it by 2. So x minus 3 over 2 squared plus the 2 from my original part here minus this part. So I now take that, and that will simplify down to 9 over 2. 2 times 9 over 4 is going to be 9 over 2, otherwise known as 4.5. I'll convert that to a decimal. So now I have 2 times x minus 3 over 2 squared minus 2.5. My vertex then is at a positive 3 over 2, which is 1.5, and my y value is negative 2.5. There's my vertex. My stretch factor again is 2, and I can graph that parabola.